when you guys are doing integral calculus, there's a lot of different types of integrals. You guys are just scratching the surface. Now, this one is generally a more difficult integral to do, but it's totally possible. You guys can do this. And so over here, I have for you guys a reminder of the derivative of inverse trig functions. Okay, it looks like I cut this off a little bit, but that's okay. You guys know that's a 1. All right, you're going to use mostly this guy and this guy for this practice. And so what you're trying to do, I mean, ultimately what your goal is you're trying to make whatever's inside the integral look like this. But don't, not with the x. Actually, I wish it said something like this. Let's not even do that part. Let's just go 1 over the square root of 1 minus something squared. This is what you're trying to make it look like. And if it was inverse tangent, it would be 1 over 1 plus something squared. Okay, so this is our goal. Now, clearly on this one, you see the integral sign, so you know this is going to be an inverse sine function. So you know this one's not going to be the answer. So let's move forward now. How can we rewrite that so that it looks like this? 1 minus something squared. Oh my. All right, here we go. Yeah, let's start like this. Let's just write 1 over, and what I'm going to do is I'm going to group together. Now I'm going to write extra, so maybe you guys want to wait till I finish so you know what to write. I'm going to write extra here, and what I'm going to do is I'm going to group the two x terms together because that's what I'm going to complete the square with. Now you cannot, well, you can complete the square when the negative's there, but it's easier to complete the square when the negative is not there. So I'm going to take that negative out and put a negative out there in front. So this is what we got. So let's rewrite it. So we have negative x squared plus 4x plus blank. Now, because we're doing a plus blank, we have to then subtract that blank. Now, technically, it's a minus blank because if you distribute this, but we'll get to that in a second. So this is all in the square root, all under 1. Okay, so what would I add to this so that it would be a complete square? Well, back in the day, you guys probably worked on this before. Like if you had 6x, what would you add to this so that this is a perfect square? Or what would you add to this guy so that it was a perfect square? Actually, let's make this one negative just for fun. So what you do is you would take the 6, you divide it by 2, and then you square it. You would get 9. So this would be a 9. And then you can know that this is x plus 3 squared. If you're like really fast with factoring, this is a complete square. It's a perfect square polynomial, and this is how you can write it in factored form. That's actually what we want. Why? Because it's something squared. Remember, something squared. That's what we want. Okay, if it was this 10 down here, you divide it by 2, then square it, you get 25. And so you can rewrite this as x minus 5 to the second power. Why? Because negative 5 times negative 5 is 25. You add 2 negative 5s, you get negative 10. There you have it. That's how you complete the square. So what would I add to this one? Well, it'd be 4 divided by 2, which is 2. Then you square it, you get 4. Not a good problem to teach with, but because some of you guys are just like, oh, just copy the 4. No, that's not how you do it. You got to divide by 2 and then square it. But now I can rewrite it. I can rewrite it like, oh, don't forget, we got to put the 4 over here. Now, technically, right, if I'm looking at this right, I'm actually adding a negative 4, right? I'm adding a negative 4. So we must subtract a negative 4. Whatever you add, you must also subtract so that you're allowed to do it. So I'm not technically changing anything. So now if I rewrite it, this is how it would look. Negative something squared, and then you have plus 25. Because when you subtract a negative, you're really adding the opposite. So we have a 25 there, and then boom. I don't know how you guys feel about that. We have our something squared. And now I'm going to rewrite it again, just because I want to make it all clean and pretty. Usually, the something squared is second, right, like this. See, something squared is second, something squared is second. Sweet. Okay, so what do I also have to change? Because this isn't exactly like this. See, if I were to read it, I would say 1 divided by the square root of 1 minus something squared. But here I go 1 divided by the square root of 25 minus something squared. Okay, so if you said that 25 needs to go away, you are right. So here I go, more writing. So I'm going to take that 25 and I'm going to factor him out. So it's going to be 25. And then I'm going to get 1. So I'm factoring him out of this. And then I'm going to have x squared, or x plus 2 squared divided by 25, because I divided the 25 out. Okay. Ooh-wee! Now, I'm going to write more. Hopefully, maybe it'll help it make sense. I can take out that 25 and give him his own square root. And now I can actually take that out of the integral. Okay, but we're not quite done. We're going to leave that there for now. I want to figure this out because we still don't have 1 divided by the square root of 1 minus something. It's like something squared, okay? Because this guy is not inside the squared. So how would I change this 25 so that I can go something squared? How would I change it? I'd make that 25. Yeah? Oh, you guys aren't seeing it?
Sorry, I'm like, huh?
Yeah, go ahead.
I'm kind of confused. Okay, so like, why do you divide by 25 but it's still in there?
Okay, because here, let me take it out. If I had 25, and let's just say there's a y right here, and if I factor out a 25 from this, I rewrite it so 25 is out here, what would be inside my parentheses? If I took a 25 out of this, what would be inside? Well, this divided by 25 is 1, right? And then this divided by 25, well, that would just be this divided by 25. Does that make sense? Yes, no? Maybe. So that's why this is dividing by 25. I can't take a 25 out of this. I can't take a 25 out of this. And so you just write divided by 25 because that's what you're doing when you factor. You're dividing each of these by whatever you're factoring out.
Yeah, I understood like why you're dividing it, but I just didn't understand why the 25 was still being multiplied. But I get it now.
Okay. All right. So we're going to ignore the square root of 25 there for a second. Okay, and the reason, if I lost you right here, the reason why I can write it with 2 square roots is because of something you guys learned about square roots a long time ago, and that was like if you had, I don't know, the square root of 4 times the square root of 25, you can write that as the square root of 100. You just go 4 times 25 to get 100. So this is actually the same. Oops, 4 times 25. This is the same as this. And I can prove it. Check it out. What's the square root of 100? That would be 10. And what's the square root of 4? That would be 2. What's the square root of 25? That would be 5. And 2 times 5 equals 10. So see, we're good. So that's why I'm allowed to do this. I'm allowed to take the 25 out of there. All right, so back to this 25. Let me show you how you would write it. You would say x plus 2 divided by 5 squared. So that 25 became a 5 inside the squared, which is really nice. That's really what we want because now I have, there's my square root of 25. Now I have what we wanted all along. We want 1 divided by the square root of 1 minus something squared. 1 divided by the square root of 1 minus something squared. That's what we've been wanting the whole time. So I just rewrote the whole thing. So that's now what I have. Okay, so let me finish this up. Let's put the dx here. Let's put my square root sign right there. Now we're back to where we were. This is now this guy. Oh, dang. So I could take out the 1 over square root of 25, which is actually just 1 over 5. So I have 1 over 5 square root of 1 over 1 minus x plus 2 divided by 5, square root of 2, square root of that, dx. And now we have to do the integral. And we have to use substitution for this. You thought that the worst part was over. Now we have to use u substitution. Oh my goodness, u substitution, no. Okay, what is u? U is x plus 2 divided by 5. That means du is going to equal, divided by 5. That's just like having a 1/5 in front. Let's do this. I'm going to rewrite it so you guys will like taking the derivative better. Let's say u equals 1/5 x plus 2 over 5. So I just divided the x by 5 and the 2 by 5 and rewrote it. Is that prettier for you guys? I hope so. And now we have du. What would that equal? What's the derivative of this? That would be 1/5. And then derivative of the constant is 0. And so then I have my dx. Boom. I had the two things I can sub in. I want to sub in the u. I want to sub in the du. Okay, so now I rewrite it. So I have 1/5. And then I have 1 over 1 minus u squared. And then dx. So I sub the u in. Now let's sub the du in. Now we need a 1/5 dx. I see the dx. I see the 1/5. So I can take both of these out and just put du instead. And now what's the integral of that? The integral of that is sine inverse u. And then plus c. To end it, we have to sub the u back in. So our final answer is sine inverse, or you can write arcsin 1 over 5. Actually, let's do this. Let's write the pretty fraction. X plus 2 divided by 5 plus c. Let's see how Khan wrote it. Sine inverse x plus 2 divided by 5. There he is. Oh, I could have crossed this guy out too because he says arctan.